Hi, this is Professor Fernandez, and in this video, this is the Lesson 2 Video 1. We were going to talk about domain and range, and then a little bit later, graphs of functions. The examples, again, come from the book that we're using in the course that I wrote, which is Calculus Simplified. So let's take a look here at the first example. This is from Appendix B, Example 1, and it says find the domain, and it gives us two functions here. So the points of this, this is literally the first example in Appendix B. So, finding domain we're going to do lots more of later in later videos and later in the course. But I want to start very, very elementary. So let's look at this function g of x equals 1 over x. You might remember that the domain is the set of inputs, right? What can I substitute in as a value for x into this function without anything going wrong mathematically? So what's going on with this function is that it is taking the value of x that I choose, and then it's creating its reciprocal, right? So 1 over x. If you think about all the possible numbers that could result, you might get some things like 1/2, maybe 1/10. Also negative numbers, maybe -1 over 2, -1 over 3. So it seems like almost any number x would work. The exception is x equals 0, right? If we try to calculate g of 0, we run into 1 over 0. That is not defined. Division by 0 is not defined. So this is not something that we can use as an input for g of x. It gets us into trouble, if you will. So the domain for g of x, you can write this in various ways. So part of the point of this video is to introduce you to notation. To review some of that. So you can say all real numbers except x equals 0. That is a very verbose way of writing it. You could also write this in interval notation, which is a bit more compact. So I'm just going to write it out first, and then explain what all these symbols mean. Okay. So this first one is an interval. This means the set of x values that are between -infinity and 0. Okay? Anytime you see a parentheses in an interval, remember that means exclude the point. You never include infinity or -infinity because it is not a number. It's more of a concept. And in this problem, we want to exclude x equals 0, so that's why we're putting a parentheses over here. This interval means all the numbers that are therefore between x and infinity, right? So another way of thinking about this is these are all the, over here, these are all the negative numbers, these are all the positive numbers, and one thing we have excluded therefore is 0. So that's exactly what we wanted to do here. And this little u means union. So this means that we're saying that the domain is all the negative numbers and all the positive numbers, right? All the negative numbers plus all the positive numbers in a sort of set sense. Okay, so that is the domain for this function, and again, a little review of interval notation. So let's slide on over then, and let's look at f of x equals x plus 4. So this is an example of a linear function. We'll talk more about linear functions in subsequent videos. But in terms of the domain, so what are the set of inputs, the set of x values that I can put in here and nothing goes wrong mathematically? Well, so, one of the ways you answer a domain question, at least initially where we're doing this right now, is you think about the function itself. That's what we did over here. We said, oh, we're dividing by x. And eventually we realized we can't divide by 0, so we have to exclude 0. So thinking about this function here, what is being done to x? Well, we're taking x, and then we're adding 4. Okay. So the question is, what are the set of all numbers, what's the set of all numbers that I can put in here, and adding 4 doesn't somehow break the function. It doesn't result in division by 0, a negative number under the square root, or some other issue where the output is undefined or infinite or something. And you can think about this as long as you want, but long story short, the answer is all real numbers, right? We can put in whatever value we want for x. And you can certainly convince yourself that all of the usual suspects, like x equals 0, would yield 4, right? So that's fine. Any negative number, you just add 4. Any positive number, you just add 4. And those are all the real numbers, right? All the negatives, all the positives, and 0. So the domain here is all real numbers. Again, that's sort of the English way of writing it. You could also write it in interval notation, right? So now, again, we're saying here all of the x values between negative infinity and infinity. Those are all the real numbers. The last way, just to introduce a little tidbit of new notation here, is this symbol. This is the set of real numbers. Okay? So, in my class, any one of these three will do, right? If I'm, if I see this on anything you turn in, it's great. It tells me that you know how to find the domain, and you perhaps have multiple ways of representing your answer. Okay, so that's just find the domain. I want to move now to the range. Okay, so let's talk a little bit about the range, and then talk a little bit also about reviewing how we graph functions. So this one is graph f of x equals x squared, and then determine its range. Okay, so the first thing I'm going to do is I'm going to set up my axes. Remember, on the horizontal axis, we put x, vertical axis, we put y. So if I'm graphing f of x equals x squared, it's the same thing as graphing y equals x squared. So that's how x and y are related. So I don't have much to go with here, right? This is not a type of function like a linear function where I have techniques, like I have a slope and I have an intercept, and again, we'll review that in the next few videos. But I had some sense of what this function looks like. This is a typical, prototypical parabola. So you've probably seen what the graph is already in your algebra class, and you can kind of guess what it's going to look like and see it already. But I'm going to take a different route just to review some of these concepts. So the route I'm going to take here is doing a point chart here. So I'm going to pick a few values for x, right, the usual suspects, and y here is x squared. So if y equals 0, then I'm squaring that, I get 0. So I'm going to write down here the point x comma y that I will then plot on the graph. So 0 comma 0, that is right there. I'll do a few more of these, and then I'll connect the dots in a way that hopefully reminds you of what this graph looks like. How about x equals 1? So if I square that, then I get 1. So if I pair them together, 1 comma 1. How about x equals negative 1? If I square that, I also get 1. So negative 1 comma 1. Okay, so I'm going to plot these points here. If x is 1, y is 1. There we go. If x is negative 1, y is also 1. There we go. So even from these 2 points, or 3, you can start to see that there's some symmetry in the graph. If x is 2, the rule for this function is just square whatever input you put in. So if x is 2, y is 4. And then if x is negative 2, well, negative 2 times negative 2, the negatives turn positive, so I get 4 again. So we can see the symmetry here. And then, of course, if I were to do enough of these dots, right, if we had a very, very long time and absolutely nothing else to do, then we would fill in all these dots and we would start tracing out the graph of the function, which is the graph of a parabola. Okay, so again, that's a quick review of how you graph functions, at least if you have no sense of what the function is. If it's not a linear function, you don't have a sense of slope, or you have other information, you can just make a table of values and then plot these points and connect them as best you can. So what about the range? Well, remember, we just talked about the domain as being the set of x values you can put into the function without anything going wrong, the set of inputs. The range is the set of outputs. So after you've put in all those x values without anything going wrong, what are the set of outputs, the set of y values you get? In terms of a graph, right, one of the nice things about a graph is that you can tell what the range is by looking at the set of y values, right? Remember, we said initially that y lives on the vertical axis, up and down. Okay, so this graph, if you notice, only lives up here, above y equals 0, and also including one point that is at y equals 0. There is no part of the graph down here. Okay, so in terms of the outputs, the values of the range, right, there is no negative y value that this function outputs for any x value. There is one y equals 0 output, and that comes from over here, x equals 0. So y equals 0 is part of the range. And then anywhere else, if I pick a y value here, right, there are always 2 x values that yield that y value. Pick one over here, same thing. Pick one over here, same thing. So I'm doing a visual argument to convince you that the range here is, and I'll do the same thing as before, express it differently, the set of y bigger than or equal to 0. So the set of y values bigger than or equal to 0. Again, there are no negative y values that are produced for any x value you substitute. Okay, so we can write this in interval notation. We can say 0, we're excluding it, so we put a parentheses, right? So this, oops, sorry, I misspoke there. We are including 0, right, because of the greater than or equal to 0. So we put a bracket, okay, and then we're saying we're going from 0 all the way to the largest number you could imagine, right? So we're going to go all the way to infinity. Again, infinity is not a number, so this is exactly how we denote this set, right? Start at 0, go on forever. So this is the two ways to denote the range here. Okay, so last thing I want to do in this little quick tour of domain and range and graphs of functions is to consider, to revisit, I should say, some of the terminology that we've been using, right? So we know, for example, that f of x is the input, f of x is the function value at that input. That is also the y value on the graph. Great, so we've kind of reviewed all that. Now let's look at a little bit of a sort of a capstone, if you will. So let's consider this example b.3. There's a function graphed here from figure b.2 in the book. First question, what are f of 0, f of 2, and f of 5? Okay. All right, so the assumption is that this is y equals f of x. And to find f of 0, we want to go to x equals 0 and then find the y value. So x is, x is over here, horizontal axis. Here is x equals 0, and then we want to find the y value. So the y value is right there. So we're going to say f of 0 is 1. Okay. Similar thing, what about f of 2? Well, we want to go to the x equals 2 location. X equals 2 is here, and then we want to find where the y value is. We have to go all the way up to here. That looks like it's 5. So f of 2 is 5. And then f of 5, well, we want to go to x equals 5 over here, and then search for the y value. We have to go down here, and that gives us negative 4. So f of 5 is negative 4. Great, so those are our y values. Question, what is the domain of f? Okay, well now we're answering this question using a graph. So it's kind of like the discussion we just had about the range. Remember, the domain is a set of inputs, the things you put in. The inputs are the x values. So we're looking on the x-axis, and we're looking to see how big is that set, the set of inputs you put in. Well, one thing you notice is that the graph is confined, right? The graph is only from here all the way to here, right? There is no graph over here. There is no graph over here. Again, I'm thinking left and right because we're talking about x, the domain. Okay, so that tells me that because the graph is confined basically from here to here, right? What are the possible x values that we substitute in? Well, they are between 0 all the way up to 5. And there is a y value at 0, and there's also a y value at 5. So the domain of f is between 0 and 5, and we include both of those numbers, bracket 0 to 5. You could also write this as 0 less than or equal to x less than or equal to 5, right? Those are the two most common ways of expressing the domain here. Great, and then last question, what about the range? So now we're going to do a very similar analysis. However, instead of thinking left and right, we think up and down. Remember, the range is a set of outputs. That is here on the vertical axis, okay? So let's look at the extent of the graph in terms of the vertical axis. Well, there's stuff all the way up here, and then there's stuff all the way down here. So the graph is in here, right? There is nothing over here, and there's nothing over here. So the largest y value over here seems to be y equals 5, and that is actually attained. The graph gets to there. The smallest y value is over here. That's negative 4. That's actually also attained. So, another way to visually represent this would be with the brackets, right? Our range, therefore, goes from negative 4 in the y direction all the way up to 5. So negative 4 all the way up to 5. And then if we were to write that in interval notation, we'd have negative 4, comma 5, and then brackets on both because both are actually y values of the function. Great, so I'm going to erase all this so we can kind of see the graph one last time and then confirm all this. Domain from x equals 0 to 5 makes sense. And then range from y equals -4 to 5 also makes sense. Great, so that's it. So we've done the domain and range review, and then also talked a little bit about how we understand what these notations mean. All right, see you in the next video.